non-zero number to a negative power. What did we just discover? Does not make the answer negative. It does not make the answer negative. Don't ever let your brain try and fool you that way. Taking a non-zero number, and that means we're talking about all positive numbers. When you're taking a positive number to a negative power, it does not mean you're going to get a negative answer. Taking a non-zero number to the zero power does not make the answer. Oh, there was one person in here, and maybe more of you, that they just didn't speak up. When something's to the zero power, we think, well, when you take it times zero, you get zero. Yeah, so taking something to the zero power does not make the answer zero. Okay? Does not make the answer zero. What did we discover? It makes it what? One. Okay? So here's what we can count on. When x does not equal 0, so in other words, our base is not 0, x to the 0 power will always be 1. Always. Okay, now I do want you to do a little experiment for me, though, to make sure that, because if you can make a liar out of me, then we're going to go with it. I want you to take something and take it to the 0 power in your calculator. Anything other than 0. Can't take 0. It says x can't be 0. You pick a number, and you take it to the 0 power. Now remember, if you take a negative number to a power, which, by the way, you can pick a negative number. If you take a negative number to a power, what does it have to be?
Positive.
No. What does it have to be? What does it have to be? Put in parentheses. So if you're going to take a negative number to a 0 power, put it in parentheses. Okay, and I would like some people in here to take a negative number to the 0 power. And I would like others of you to try and take a positive. The only number we can't take to the 0 power is 0 itself. Anybody want to tell me what's happening?
Getting 1 every time.
1 every time. How about anybody else? Riley, what's happening on your calculator?
Nothing, I don't understand.
Okay, do this for me. Take 3 and raise it. You might have to look for this key, the upside down V key, on your calculator. 3 raised to the, so you hit 3 raised to the 0 power. Just do a 0. What do you get?
1.
1, okay?
-7 to the 0 power, and I still got positive 1.
Okay, even without parentheses. Okay, parentheses. Would you try without parentheses, though, right? And then, so since thank you for trying a negative number, right? You tried -7 to the 0 power, and he still got 1. If you can't figure out how to use the power key in your calculator, it might be an upside down V, it might be a y to the x power key. Now it's a negative 1, isn't it? Because here's why. It says, I'm going to take 7 to the 0 power, and then I'm going to take its opposite, because you didn't put it in parentheses. So that's what happened there. Okay, so we can count on that all the time. I think enough of us tried it, I hope, that we can count on that. Nobody disproved it. Anybody disprove it? Okay. Well, when we take x to the negative n power, what do you think we can always count on? Let's look over here. Fraction. We're going to need a fraction, and even more specifically, we're in a fraction where we have, what happens is, so look at here. For 10 to the negative 1 power, we ended up with 1 over 10. And isn't 10 to the what first power? So in other words, couldn't I just put a 1 here right now? Would that be true? Did I change its value?
No.
Okay. Could I rewrite this one as 1 over 10 to a power? 10 to the second power. So notice what happened. The exponent became positive, but it had to be downstairs for that to happen. Okay, so we're going to say we can always do this to get rid of a negative exponent. We can write it like that. Well, here's another thing we can count on. What if the negative exponent is downstairs? It can move upstairs. So this will become x to the positive n power. We'll get rid of the fraction, in other words. So when we have something being taken to a negative power, it will become a fraction. When we have a fraction with a negative power downstairs, it's not gonna any longer be a fraction. Okay, so those are things we're gonna count on. Those are properties that we can count on all the time. And then I wanna go through some things that I have to make sure you register up here and say, you know what, I better follow these rules or things aren't gonna go well. Okay, so negative, and then a 2 to the 4th does not mean the same thing as negative 2 in parentheses to the 4th power. I keep saying that, don't I? Here's what the first one, only the 2 is taken to the 4th power. This negative sign is not part of the power, it's by itself. It's like what do you suppose I could put with that negative sign? What do you think I could put right behind that negative sign?
1.
A 1. I could make this into a 1 right here. I would say that is a negative 1. And then 2 is going to be taken to it times itself 4 times. So does anybody just happen to know what 2 to the 4th power is? 2 times 2 times 2 times 2. 16, yeah, 16. And then negative 1 times 16 is? Negative 1 times 16 is? Negative 16. That's the value of it when it is written this way. That's its value when it's written that way. Now if I put that negative sign inside parentheses with the 2 and take that to the 4th power, that is saying take negative 2 times itself 4 times. Well, a negative times a negative,
Positive.
positive times another negative, negative times another positive, positive. And 2 times 2 times 2 times 2?
16.
16, so it's a positive 16. What did I do? Not the same thing, is it? When we do it this way versus doing it this way, we don't get the same value. And it isn't this easy. It isn't take the eraser on your pencil and just erase the negative sign when the key says it shouldn't be there. We gotta understand why it shouldn't be there, or why it should when it should be there. Okay, I want you to evaluate for me this one. Go ahead, try it. Evaluate that. No calculator. No calculator. Try and figure out the value of the expression at the bottom of your page there. See if there's anybody in here you can agree with. When you're done, find somebody else who's done, see if you can agree with each other. There's only one answer. Okay, class, and the answer is?
8.
8. Positive 8. Okay, not negative 8?
Nope.
Oh, so how'd you get that? What did you actually have to do, Smarky?
Negative 2 times negative 2 times negative 2. And negative 2 times negative 2 is positive 4. And then 4 times negative 2 is negative 8. And then there's a negative 1. So negative 1 times.
So we just did only this part right here right now, didn't we?
Yeah, and then
Yeah.
there's a negative 1.
Okay, and then we got to bring this down here. We have a negative, or in other words, what did I say we could also say instead of negative? The opposite of. So this is really saying the opposite of a negative 8. What is the opposite of a negative 8?
Positive.
Positive 8. The answer is positive 8. So that negative sign is not part of the power, is it? It's we have to give it at the end. This says take negative 2 times itself 3 times, and then take its opposite, because that negative sign is outside the parentheses. Just
So why can't we just bring the negative sign down to parentheses? Because that's what I did, and I got the same answer.
Okay, so you mean like you gave it to the inside the parentheses before you multiply it? No. Okay. Let me see. I'm trying to understand here.
This is what I did.
Oh, every time you brought it down in front of it. Oh, okay. Well, we probably, let's see. I don't think we would want to do that because of it. Let's just pick out another one to do, okay? What if we had this? Would it turn out this, would we turn out with a positive number? What do you think? This says take,
No, it's not. We didn't need
this says take the opposite of -2 times itself 4 times. Anybody think they know? Didn't we do that up here above already? -2 times itself 4 times is 16. So this would become the opposite of 16. And the opposite of 16 is -16. Now, Emerson, if you did it your way, where we would do, that negative sign, we would do -2 times -2 times -2 times, I gotta do it over here, -2, and then you brought the negative sign and gave it down to every one of them. Look at what would happen. We would end up with, these would become positive, and then we take a negative times a negative, positive times a negative, negative, and then we get a positive. You get a positive 16. So we just kind of proved that we can't do that. Okay? So we can't bring that negative sign down and let it come along with all of the factors. Okay? So we don't want to do that. Okay, any other questions? This is really important that you understand this. If you don't understand this, you're just going to be making pencil marks for the next couple of weeks here. And then you're going to be frustrated when you're wrong. Okay, let's go to the back then. We're not going to do all of these notes today. We're just going to go through this next section. So you need your book open to page 393, it says. And we will do the check it out problems. Whenever we do check it out problems, that means there's been an example gone through above it. There will be an example too that you can study on your own. So if we don't understand it after going through it in class, then you go back and you study the example on your own and see if that helps you out some more. Okay? So what do they want us to do for this check it out problem, these check it out problems, 2A through 2D? What are they asking us to do? Are there any instructions?
So check it out, but
They're telling us to simplify. Okay? So simplify means,
so.
not really solve it, but
It's simplest form.
put it in its simplest form. Rename it. So just like we can rename 3/6 as 3/6 as
1/2.
1/2. That is simplifying it. That is renaming it. It still lives at the same place on the number line. We're just renaming it, okay? So 10 to the -4. What do you think we're going to do without our calculators? On the front side, what did it say we're going to do when we're taking x to a negative n power? How are we going to write it? X to a negative n power. How did we decide to write it? Cameron?
As a fraction.
Okay. Yeah, so we're going to put a 1 upstairs. And our x this time is 10, right? And our n is -4. So downstairs it becomes a +4. So 10 to the +4 power. So it was a negative n upstairs. Our n is 4, but it was negative. There was a negative sign in front of it. So it's just like x to the -n power. So it gets rewritten as 1/10 to the 4th. And then we'll just take that another step further. We'll say, because if you don't show me this step, you're showing, and you just get the final answer, you're kind of showing me you use your calculator. And I don't want you using your calculator. We know what 10 to the 4th power is. What is it? 10,000. So this is the same as 1/10,000. 10 to the -4 power is 1/10,000. Okay. Number 2B, we have negative 2, because it's in parentheses, so we know that's our base, negative 2, being raised to the negative 4 power. What would be my first step? How would I write that first? First way I would write it. Here's my question. Isaac?
That'd be negative 2 times negative 2 times negative 2 times negative 2.
Oh, we don't want to write that much. We don't want to write that much. Trey?
What do you do?
What do I call on you? You're going to say you were stretching. Probably. Who wants to, come on, let's go, we got this. Okay, what's our x this time? Negative 2. So here's what we have, you guys. We have x being raised to the negative n power. Okay, what do we do when we have x being raised to the negative n power? How would I rewrite that now? Brighton?
Why don't it be 1 over negative 2 to the 4th?
1 over negative 2, still in parentheses because it's a negative base, and now the power becomes just positive. We ditched the negative sign in front of the n. So, negative 2 to the positive 4 power. Now we will say to ourselves, okay, we know what negative 2 multiplied by itself 4 times is. Negative 2 times negative 2 times negative 2 times negative 2 is?
16.
16. So this becomes 1/16. Now what's another way I'm going to know you're using your calculator? Oh, give me it as a? What would you do that in your calculators right now, please? Would you take negative 2 in parentheses to the negative 4 power and see what you get? Do you get 1/16? You got 16. Is that what you said? Maybe we're going to take it to the negative 4 power. You took it to a positive 4 power though. So we're taking negative 2 to the negative 4 power. Do you get the answer 1/16?
Negative 16.
I got 0.0625.
0.0625, yeah. That's using your calculators then, isn't it? And we're going to get fractions. And even I'm not saying that you can't get that calculator to do it as a fraction.
Mine can do it.
Yeah, yours can probably do it as a fraction, but we're not going to use our calculators because do you have to show both of these steps, yes or no?
Yes.
Yes.
Yes. Okay, for some of you who were tuned out, do you have to use show both of these steps?
Yes.
Yes. Am I just going to let your answer be tomorrow 1/16 for this problem?
No.
And that's it? No. You got to show using the property. This is called applying the property. Then we do the calculations in our head. Okay, so you do the next one then. And you know how. Now, we've got all the tools. Because it is. Who wants to come up here and do it for us on the board? Okay, Ariel, you can do it. I wasn't sure if you were stretching this.
No.
This time it was for real, okay. Okay, thank you. You guys agree with it? Okay, so one of the critical parts, and you look at your paper right now and make sure this is here. because I already caught a couple people without it. When you wrote your -2 downstairs, did you put parentheses around it?
Yes.
Yeah. And that is being taken to the +5 power, right? Okay, now, guess what? Ariel's right, and so are all the rest of you who have this answer, but guess what? Do you think they're going to show this in an answer bank that way? I'm not saying I want to change to decimal, that's not what I'm saying. Do you think, left as a fraction, this is the way you're going to see an answer bank, 1 over -32. Okay, how do you think we're going to see it then? Think of rise over run, you guys, come on, think of rise over run and slope, and what did we do when we had a fraction and it was negative? What could we do? Malcolm?
Into a decimal.
We could make it into a decimal, but I don't want you to. I want you to keep it as a fraction. So what could we do keeping it as a fraction? Trey?
Would they show us how it could be written the other way? So it's -32.
Ooh, is -32/1 the same thing as 1 over -32? In other words, if you took 1 divided by -32 on your calculator, and you took -32 divided by 1 on your calculator, would you get the same thing? No. So we can't do that. Gotta do legal stuff here. We don't really know what we can do. If we had a negative slope, if we had a -1/3 slope, we could give the negative sign. We could give the negative sign to either the 1 or the 3. If we made the 1 positive, then we made the 3 negative. If we made the 1 negative, then we made the 3 positive. So this is what I just said, just in case those of you who need a visual. If we have a -1/3 slope, we said that is the same as, you could use the negative upstairs, then the downstairs would be positive, or we said the upstairs could be positive and the downstairs would be negative. So what do you think we can do with what we have right there? What's it going to be shown as in an answer bank? 'Cause I'm pretty darn sure they're not going to show it that way, and then you might be a little ready to do a wild guess instead, and I don't want that to happen. Rose? Which way? What's that mean? Can it be changed to 32? I think we got this top. Can we change it to 32 over -1? Is that what you're asking me to do? No, we can't do that. We said if we took 1 and divided by 32 on our calculator, it would not be the same as 32 divided by 1. We can't do that. What can we do though? What can we do, right?
Put the negative sign out front.
Put the negative sign out front. Pull it out. And say this is the same as, this is how I would typically see it written in an answer bank. So let's do that. -1/32. Kind of long and drawn out, but we gotta understand that that's what it means, the same thing. Okay, and one more. We have a negative, and then a 2, and a -5 power. How are we gonna write that? Trey?
Since we're not supposed to write it like that, can we say it's like no solution?
You think it's no solution?
It says we're not supposed to do that. It's not the same thing.
Okay, it says it's not the same thing when we were taking it to a positive power, right? So, in other words, when the parentheses aren't there, it's saying what?
Multiply it.
What's being taken to the negative power, Josh?
2.
Just 2. Okay. So first thing we're gonna do is we're gonna say this is really the same as, this is a negative, okay, let me erase that, I'm gonna do that a little bit different. We're gonna make this so that this is a -1, that negative sign is a -1 times 2 to the -5 power. Only the 2 is being taken to the -5 power. That negative sign was not inside parentheses with it, so it's separate from it. So we're going to make that into a -1. That's going to get multiplied by our 2 to the -5 power. Okay, so now we're going to say -1. Do we need to rename -1? In other words, does it have a 0 or a negative power? No, it's It's a negative number, but we're only trying to simplify. What we're trying to simplify is get rid of negative powers or zero powers. We don't have any zeros here today yet. So -1 can stay -1. But 2 is being taken to a negative power, so I have to rename it. What can I rename that as?
2/1.
No.
1 over 32.
Well, not right away. 1 over,
2, negative 2 5.
no,
Oh, 2 5.
2 to the 5th. It goes downstairs and becomes a positive power. 1 over 2 to the 5th. And then I'm going to go to -1 times, who wanted me, who went straight to that, Cameron, what is it?
1 over 32.
Yeah, 2 to the 5th power. We already knew that 2 to the 4th was 16. So we just have to multiply 16 by 2 and we get 32. So 1 over 32. We're not done yet because now we have to take a -1 times that. What's the answer?
-1 over 32.
Negative 1/32. A negative times a positive is a negative. 1 times something is itself. So it becomes negative 1/32. Okay, now, some of you in here maybe right now are like, oh, wait a minute, you just said there was a difference between when there's parentheses there and when there's not. Didn't I say that? And now we end up getting the same answer when there were parentheses and when there weren't. Wait a minute, LeBrand, what are you talking about? Am I talking out of both sides of my mouth, or what's going on? Can you think of any times that would not happen? Isaac?
Get 5 was positive.
Well, they would still have the same answer. If it was a 5, a positive 5 instead of a negative 5. That really wouldn't make, well, it wouldn't make any difference. Okay, here's the deal. Remember we did 2 to the 4th power? And a negative sign was out front. What was that equal to? Does anybody remember?
Positive 16.
No, it was a negative 16. 2 to the 4th power is 16 times a -1 is a negative 16. Positive 2 or negative 2 in parentheses to the 4th power, what's that? That one's positive 16. So you know what makes the difference, you guys? Here's what it is. Nope, this is what it is. This is an even power. That is an odd power. So it works for the odd powers, but it doesn't work for the even. So we just use it all the time. We say parentheses are important all the time. Okay? So I wasn't trying to mislead you. Okay, so just kind of follow the rules that we set up today, and hopefully that'll help you be successful.